Hello, we're live. Welcome everyone. Hey Christian, how you doing?
Doing well, Peter. How are you doing?
I'm all right. I'm glad that we got you to join us. This is episode it's 59. I thought it would be 60, so it's a nice round number, but I guess 59 is good as well. We have
That's
a
impressive.
yeah.
I think I looked back. I did the very first one, Hoot number 1, and I feel like that was ages ago. And I'm happy to see that. And I know there's been a lot of really good content shared through these live streams. So I'm happy to see that there's still a lot of interest, and we're keeping it going. So thanks
Yeah,
for having me.
yeah. I mean, we have great topics. I think we've tried to do it every 2 weeks, I guess.
Yep.
And it's a lot of fun, a lot of great topics. And I personally, when I do these things, I learn a lot as well because I have to prepare stuff, right, and go through it. It's really it's a learning experience for me as well. If you're joining us, say hi in the comments, just so we know that we're not talking to an empty room. I guess I don't think we are, but don't be shy. Say hi. So what are we going to talk about today? So we'll talk about JWTs versus mTLS for service to service communication. So I don't know, Christian, if you want to like give a brief, like a minute, 2 minutes background from where this topic actually came from and why did we like pick this?
Yeah. I know for technology live streams, people try to build an audience and get people to come in by talking about what's the latest, newest, sexiest type of technology. This is not that. This topic is more from the conversations that we have here at Solo and in the field, and generally, in the developer community when it comes to security. What are the approaches that we've seen people take, and an approach that anything that you have to do to try to get developers to agree on something, and then even to get the security teams to agree on something, that's usually a pretty big feat. And some of the things that the industry has sort of agreed on is these, when services talk to each other, so service to service communication, how do we know that, service A is talking to service B? How does service B know that is indeed service A talking to it? And there's a number of different mechanisms for doing that. But from a security standpoint, can we prove or can we authenticate that service A is really service A talking to service B? Now, I mean, I was a developer in the past. I've worked at big banks. As my time as a consultant, as architect, working with these organizations, we've seen all kinds of different mechanisms, from API keys to opaque tokens to custom tokens to JWT tokens to all kinds of different things, TLS, mTLS. So we've seen a lot of different things, but I think what's really interesting is now that people are going to containers, going to microservices. They're adopting some of this this technology that's better fit for these types of architectures. What are some of those things that they were doing in the past that may not fit as nicely with some of these new modern cloud, based architectures? And this is one of those areas. Kind of boring, honestly, but actually, if you dig into the details and you care about security, it gets pretty interesting pretty quickly.
Yeah.
So I think that's what we're gonna dig into a little bit today.
Yeah, I think I mean, doing air quotes for boring here, right? For me, I always try to not stay away from security, but security feels like something, if you make a mistake, you can mess it up really badly, right? Because it's security, right? Security, privacy, all those things there.
Right.
You can mess it up worse than if it's, I don't know, retry logic, maybe. Not saying that that's not important, right? But security feels like it's more, it has tangible, like, bad results in the end if it's not done well. But yeah, when I looked at Jot and all that, I'm like, well, Jot, I mean, it's easier to read, right? It's human readable. It's JSON, right? If we can use it for user auth, why not use it for service to service, right? It makes sense.
Yep.
And I mean, on the surface, and maybe it does, right? It's like, oh, it's so easy. It's there, right? It's signed. We can get it, right? Blah, blah, blah. But then you're thinking about it. So, well, you still need to like secure your services, right? Like, how do you, it's like, there's other things here. Like, you can't just do, like, you need TLS, you need mutual TLS, right? And it's not really that easy, right? When you get down into details, it can get very complex, at least from the, like, when we get to the demos, right?
Yep.
I can show some of the things, and I'm not saying I implemented this perfectly. It's just thinking about, look, I did this one thing, and it's like, okay, so this works if I have it here, but then I did a demo with 2 services, like 2 services is not, I mean, it is realistic, but not really, right? We have customers with hundreds and thousands and, services running. You don't want to do these things like that. There's no way you can scale it, right? That's what I'm getting
Right.
at. So, anyway, I know you have some graphics and things that we can go through, maybe like to guide the discussion. And I just want to bring it up. Anyone watching in the comments, tell us, what are you using, right? Are you using JWTs? Are you using mutual TLS? A combination? Are you using some third thing, some fourth thing? Let us know, and as we go through the scenarios, and then we can look at the questions, answer those, and have a discussion around it. So, all right, all ready to share your screen, Christian?
Yes.
All
Let's
good?
do it.
All right, perfect. There you go. So if it's too small, please, people on YouTube and LinkedIn, scream so we can make it bigger if needed.
Yeah, I can adjust. I can adjust the zoom here. Let me know. Okay, so the way we started thinking about this is, like I mentioned, containers, microservices, moving to the cloud, dealing with dynamic infrastructure, ephemeral infrastructure, etc. One of the first few patterns we saw that impacted developers, and people tended to acknowledge and agree that going to microservices, breaking up your services, you still have to solve the security problem, and we'll dig into a little bit about what that really means. But that instead of trying to do that in every single service and try to get it consistent, we'll leverage an API gateway, at least for that traffic that's coming in. We'll have the API gateway take care of gateway type things: authentication, authorization, rate limiting, maybe load balancing, these types of things. Getting the traffic to the services and kind of offloading some of the security aspects, so the services don't have to try to deal with that and some of the complexity that comes along with doing that. And this is a great pattern. And there's a lot of truth to doing that. Now, once the traffic gets into the system, this is where we start thinking about, how does a service communicate with another service? And a common approach to doing this is, well, let's just route the traffic back through the API gateway. And you can do that. And that sort of, if I scroll over here, it starts to look a little bit more like this, right? The traffic comes in, gateway applies its security logic, goes into a cluster, and eventually to a service. And now that service wants to talk to another service. Maybe it's in the same cluster. But to get the consistency of the policies, we're going to pop back out. And this is called hairpinning, when you come back out through where you came, and go through the gateway again. Now, there's not ideal. Certainly, if your gateway lives far away from your cluster, and certainly not ideal if you have to hop through a bunch of different load balancers to eventually get to the gateway and then eventually get back. That adds latency and more chances for failure, saturation of the network, et cetera, et cetera. A single call now, balloons into a number of additional hops and calls. Another approach that people tend to take is, well, why don't, if the services call each other directly, something like this, we still need a way for workload B to know that workload A is calling it. And we might attach an identifier, a client identifier, an API key. We might say, hey, workload A, whenever you talk to workload B, always send this thing with it, and then workload B will know that it is workload A. Now, what is that thing that you send, and how do you send it, and how does that get treated? That's those are the questions that come up. JWT is one of those options. The service mesh.
Christian, sorry, can you try sharing the browser directly instead of the screen? I think it might be too small to read.
Sure. Yeah. I've seen that. I've seen that before. Let's share the.
Yeah, and while you're sharing, a couple of comments while you were talking, Sebastian said that as a consultant, he usually sees both JWT and mTLS, right? There's so many different teams and apps. And then Christian said JWT and mTLS as well. So looks like it is the combination of both. Is this any better? Do we need to make it bigger? Asking people on the stream. Maybe, yeah. Hopefully this makes it easier to read and try different. Let's see. No, I think this one's fine.
Okay. So I mentioned, the different approaches, JWT being one, API tokens, some random header just says I am service A. The service mesh takes a very specific approach to this. And I would say it takes an approach more similar to the gateway. Okay, so what I mean by that, by the API gateway, what I mean by that is, instead of having the services go hack this together in their own code, it takes it out and puts it into a common reusable component, in this case, a sidecar or something in the path of the network, that then, it can take care of things like mutual TLS. So using mutual TLS for this authentication mechanism. And it offloads it from the application having to deal with it. But not everybody's using a service mesh, and not everybody understands the value of a service mesh. And I'll park the service mesh discussion for a moment. And what they end up doing is handling tokens, API keys, JWT in their application code. And for each language, each framework, there is good support for this in various languages. Spring Boot, for example, if you're a Java developer, has really good support for the Node.js. Has libraries that are good support for this. But the point is, each developer now needs to, somehow come up with the tokens, manage the tokens, keep the tokens secure, and a number of other things that we'll dig into that become the developer's responsibility. When originally we, rightfully, I think, came to the conclusion that having a component that handles a lot of this boilerplate, tedious, and potentially error-prone capabilities for the developer is a good thing. But if we're going to handle tokens and all this stuff ourselves, it goes right back into the developer's hands. And even if you have an API gateway, it sort of undoes what the API gateway was there for in the first place. So for service-to-service communication, using JWT tokens, there are a number of things that we need to think about. Let's see. I'm only sharing this one tab, right?
Mm-hmm.
All right. Let me see then if I do this. Let me just copy this, and I'll bring it over to this tab so that everybody can see it. All right. So here's one approach for solving the service-to-service identify who you are or authenticate who you are between the services. The API gateway is here, but ignore it. Ignore these. What we're looking at here is service A. And if we're looking at JWT tokens and getting the JWT tokens, there's a couple different approaches for this. The first that we'll talk about here is, service A will get a JWT token that says, hey, I am service A. And it can do that a number of ways, but this way that we'll look at, it'll talk to some identity provider. It'll use some mechanism to prove that it is indeed service A, username and password, client credentials, OAuth2 flow, which also uses basically a username and password, and get the token, right? Now we get the token, and then we're going to call service B with it. When service B gets this token, it should be able to validate that the token has been signed by a provider that it trusts and nothing's been tampered with, right? There's the signature will validate that nothing's changed. Now, in doing so, we have to have a couple things in mind. The developer needs to think about this. Number one, when we send this JWT token, it's representing service A. If it gets leaked somehow, and it's actually not that crazy of a thing to think that a header going over HTTP in a network on-prem might get leaked, various server logs or whatever. If that token gets leaked, somebody else can take it and say that, hey, there's service A, and send it to service B, right? So what we want to do is we want to have some way of protecting that token, and a common way that we see is people do one-way TLS. So service B will present a TLS certificate saying, hey, I'm service B. Service A trusts the signer of that certificate, and we establish encryption between service A and service B, and then we can send the JWT token. Okay, that sounds good. We also need to have an expiration on this JWT token. We don't want these tokens long-lived because, again, like I said, if they can be recovered somehow, it gets leaked, they can just use those tokens for as long as they want and pretend to be service A and call service B, and service B will accept it. That's sort of the drawback to some of these bearer token approaches. What you're putting on the wire is the secret sensitive material that represents you. And so in this case, since JWT doesn't really have a good mechanism for revoking a compromised token, we have to put expiration and think about what that expiration window will look like. For example, I think at places like Netflix and Google and others, they have very short expiration times for these types of credentials, like 4 minutes, for example, or a minute, or even less. Another thing we need to think about is the audience for the JWT token, so that service B, when it gets a JWT token, it'll validate that indeed this is for me, intended for me. Because if a token doesn't have an audience, it can then just get replayed. Potentially service B is a bad actor and can just replay, talk to service C and say, hey, I'm service A. Look, I have the token. And so we want to check for audience, for expiration, identity provider that we trust, and so on. Now, this might not be new information to you. Anybody doing JWT hopefully understands some of this. But we don't see this applied consistently. We don't see very short duration expiration on JWT tokens. Sometimes they're either very long or not set at all. We don't see audience always set on the JWT tokens. And security breaches don't happen because you leave a massive gaping hole in your security infrastructure, right? It happens because of these little things that an attacker gets into a network and then starts to prod and poke and see, all right, where are things kind of not up to snuff, and then exploit that and move to the next one and the other thing and so on. And it's a cascade of different things that happen.
It's like breaches by 1,000 cuts, right?
Exactly. And so it's on the developer to be thinking, all right, when I call service B, I need a new token. I need one that expires very quickly. I need the audience to be set. I need to refresh these tokens if I'm calling service B. I need to think about, well, what if the identity provider says I need to invalidate my key? How do we think about rotation of the key, the certificates or the keys that get trusted for validation of the signatures? There's a number of things that the developers have to think about, and it's on them to do. Now, this is true for a single service, and it's also true, let me copy this one in, when you call multiple services, right? Setting up the correct audience, correct expiration, and thinking about, if I call 3 services, 5 services, I need different tokens for each of those services if I want to do this right. And each of those services needs to check the expiration, the issued at time, not before time, the audience time claim, and all of those things. There's a lot of things that the developers need to be thinking about and actually doing to get this right. The second approach is, well, maybe we don't want to call an identity provider every single time. I've seen this just as equally. It's hey, service A has its own keys, and it's going to generate its own JWT, and it's going to sign the JWT and send it to service B. Now, service B has, ideally this is a asymmetric key pair, asymmetric, so there's a public and private key. The service A holds onto the private key and shares the public key with everyone else. So ideally, service B has the public key of service A and can use that to verify that, yes, indeed, this is service A that signed the token. And again, audience expiration, all of that stuff needs to be accounted for. Now, I want to pause here. I think Peter mentioned earlier, at the beginning, ask questions, push back if you're, if this is something you would never see and never do or whatever. Please let us know. These are things we certainly have seen, and they're people do them. But I want to pause here to see whether there's any questions, and then also to jump to Peter. He's going to show you what this actually looks like in code.
Yes. Yeah. Let me. And as Christian said, just feel free to ask questions. And for this specific scenario, it feels like when we looked at the previous one where there was an third party or external provider or whatever you want to call it, something that deals with identity, right, and auth and everything. It's almost like that job or role in that case is taken on by service A in this scenario, right? In a way, right? So that's service A. But then this is just when I was implementing these demos, and we have a GitHub repo with like more demos than I'll show today, right? And you'll be able to go through all the scenarios, right? And I did the very simplest implementation possible, right? 2 services. But then if you think about further, right, you don't have service A and service B. There's service C, D, E, F, G, right? There's a lot of them. And if you think about each one of them, like in this case, service A acts as a token issuer, right, for that service. But then service B might be calling service D, which means service B is a token issuer for itself as well. So you have this replicated everywhere. And then if you think about the private and public keepers, right, you need a public key in order to validate, right, verify that the token was signed with the correct private portion of the key. Each one of these services needs to have those public keys in order to be able to verify. So it's almost like you're baking in
the dependencies, right? Think about how keys are either revoked or rotated.
Yeah. I mean, I'm just thinking, imagine all the dependencies a service can have, right? And imagine that service needs to know about n number of public keys. And then if you put into that the whole, now we have to like rotate all those keys, right? It's a nightmare. Anyway, so there's a question from Sudhindra. How can JWT service-to-service authorization be used in case of TCP services? Are there any tunneling protocols where we can embed JWT tokens?
Yeah, so JWT stands for JSON Web Token. It's typically used in the context of HTTP. It doesn't have to be. You can, it's just a way of formatting a set of data. There are protocols that, binary protocols that maybe you would pack a JWT token into. Actually, HTTP2 is a binary protocol and supports JWT. I would say, we're talking about JWT. We're not advocating for JWT here. What we're showing here is this is the way we've seen people do it. And if you're going to do this, these are the things you have to take into account to do it right. However, there is a lot of detail and ways for the developer to get this wrong, to the extent that we believe, or at least our position is that what we do in a service mesh better handles this use case and minimizes the drawbacks of the complexity of the developer having to do this. So in the service mesh use case, can we solve service-to-service authentication and identity? And the answer is yes. We don't need to be thinking about tunneling and protocols and all this stuff. We'll use mTLS. And like I said, as we go, we will show in more detail how mTLS through service mesh is probably a better and safer approach to solving this problem than letting the developers in Node.js, in Java, and Golang, and Ruby, and Python, and all this stuff go try to figure out how to deal with JWT tokens.
Yeah, and we haven't even talked about like the authorization part of it, right? Because if you want to use JWT, I mean, yeah, you can use it with JWT. You basically prove that, oh yeah, I'm service A, right? And it's meant for service B. But then how do you say, oh well, with this token you can only call /API/v1 endpoint and only use post methods to do that, right? That's like a whole another layer of complexity that you can. I'm not saying it can't be done.
You can build that on top of JWT. And I want to be clear. I know we said this at the beginning, but I want to restate it, that we're talking about JWT tokens for service to service communication, authentication between the services. JWT tokens, ID tokens that represent an end user, those are fine. There's just a nuance to that too, but that's not what we're talking about here. So I just wanted to also point that out. And make that
it's service to service specifically. There's another question from Christian. He's asking, can I make the expiration a mandatory claim in an auth policy? It seems like Envoy treats it as optional, and because it is numeric, I can't mandate it with auth policy.
This is an Istio specifically.
Yeah, it might be Istio. But I think that Istio does like fail if the token is expired, right?
He's asking whether to check whether the claim is there or not is mandatory.
Anyway, we can. I can take a look. Yeah, if you know the answer, Christian, go ahead.
I don't know the answer definitively off the top of my head. I know that we can, and I get confused a little bit between what we have in Glue and what is available in open source Istio, but I know we can enforce that there are specific claims.
Yeah, so Christian saying this is Istio, yes. Yeah. I know there is a way to like use claims in the authorization policies. I'm just not sure if there's any nuance with as Christian said, be it, because it's numeric. You can mandate it. But definitely, I'll check it out, Christian, and I can reach back to you after this stream and see what I can find out. All right, let me share my screen quickly, and I know people will complain that the font is too small. I'll try to make it bigger, but so I just want to show the scenario that Christian had there, where I have two services here on the bottom left. I'll run service A, and then on not port B, but on the second side, I'll be running service B. So this is the scenario where service A acts as its own issuer of the JWT token, and when I call from this upper window here, when I'll make the call to service A, what service A will do is there's a set of keys that I've pre-created already, right? So I have private and public JWT key, which is used for signing the JWT, and then the public JWT is used by service B to verify that the token was signed by the private key. And then I also have the server public and private because I'm running TLS, right, on the service B side, right? So service A will load the keys. It will create and sign a JWT token with the subject of service A, an audience of service B, because we're calling service B. And then it's going to send just a GET request with that JWT token and the headers to the HTTPS endpoint, which is service B, right? And then what service B does is it's going to read the token from the auth header. It's going to read, in this case, it's the same folder, but we're not trying to recreate like a production scenario here, right? But it reads that public key from that service A used the private part to create and sign the tokens. It uses a JWT library, right, to verify the token was signed with the correct key and that it contains the correct subject. So it's checking that, yes, this call is coming, right? It's coming from service A, and audience is for service B. It is for me, right, for the service, and then it's just going to respond. So let me try to make this call. I think it was scenario 3, right? So if I do localhost, and this isn't going to be like nothing too crazy unless it fails, which it might, but it didn't, right? So anyway, so what happened? I got back a response saying, oh yeah, the token was valid. Here were the claims, right? It was a service issuer, so this should be service A, right? But it doesn't really matter. Subject was service A, audience was service B, expiration, and the other claims that were created. And when Christian was talking about trying to make the expiration as short as possible, right? Because if this is measured in years or months or days, if this gets out, anyone can basically make the call. I'm actually setting the expiration to like 1 second because I'm running everything locally, right? So this key that was here that was already used, this one here that I'm you can see here, it's in the authorization header, right? This one is already expired, right? So now this looks like, oh, it's working, it's easy, right? But there are just so many things that you have to like worry about, right? The keys itself, right? And this is one service to another service. Now, if I would go to service B, maybe I own it, maybe a different developer owns it, right? They will have to do pretty much very similar things, but maybe a little bit different, right? They'll have to, we talked about having the public keys of all of the dependencies, right? And all of the services that might call you just in case you need to verify the JWT tokens. But it's also the thing that we didn't talk about, right? Is the whole, well, let's try to do authorization with this, right? And I think that would be, I started thinking about it and I'm like, there's just like infinite ways of you could go about doing this and setting it up with claims. And, like I even tried to mimic what Istio is doing with authorization policy, right? To say, oh, this is allowed methods, allowed like paths and everything. And sure, you can do it, but I think it's just a pain. It's very, very hard to manage. And I was having like hard time with 2 services and trying to figure out, how to coordinate. it's not the implementation. You can do it once. It's just the stuff that comes afterwards, right? Where you have to maintain this, rotate the keys, restart the services, right? Reload. It's just a lot of things to worry about. Should we move to the next scenario, Christian? I can also show, I mean, this is just an expired scenario, but this is not much. Like in this case, the service A will issue an expired token, right? And then this will just fail that the token has expired, right? We'll be able to make the call, but then the call on service B side will fail, right? Saying that the JWT was expired, right? All right. Let me switch back to you, Christian.
Sure.
There you go. It's all yours.
Okay, awesome. So now if we take a step back and let me find my screen. So the point that we've made so far is that, so we've seen organizations do this. We know there's a significant amount of complexity in getting this right, and it's on the shoulders of the developers. How do we mitigate that, or what is an alternative? The alternative, as we hinted or even explicitly said, is if we do this in mutual TLS, we get a lot of this stuff out of the box, and without the developer having to worry about shuffling around these JWT tokens. And in fact, if you're going to do JWT tokens the right way, you have to have one-way TLS anyway. So you're half the equation for mTLS is basically already solved. It's already there. And so it's not a big lift to then go to mTLS when we talk about doing that through the lens of the service mesh. Now, if you're going to try to do mTLS directly in your code, that's not much easier than the JWT tokens, honestly. They're very similar. You have to worry about the same things. Loading the certificates correctly. You want short expirations of the certificates. Rotating the certificates. Those are things that are not that easy with trying to hack them into your code directly. So if we take a look at, let me see, is this the right image here? Yeah, kind of. The way the service mesh thinks about this is the sidecar or the component in the service mesh is, actually, let me see if I can find a slightly better, give me 1 second.
While you're searching for this, just to answer,
Yeah.
Christian, I did check the docs. It looks like there's a way to get the claims in the authorization policy, but he's completely right that right now it only supports claims of type string. So there's no, and if expiration is a number, there's no
way to say that this claim has to be there.
There is a way to, I think you can say that the claim is there, but you can't, I think you can just do a star, right, to say that the claim is there, but that doesn't tell you if it's expired or not, right?
But I think the way that I read his question was whether the claim was there. So he wants to test whether it's expired and reject the expiration.
Or just use it as part of the, like a if statement, I guess, in the rules. But anyway.
Okay. The diagram I have is not exactly the diagram I want, but in the service mesh use case, basically the agent that represents workload A, and that could be a sidecar, but it doesn't have to be. I think we've done a number of Hoots on Istio ambient mesh that uses a sidecar-less approach to solve and this exact same problem. It works very similarly, but workload A then has a sidecar that runs that then takes care and automates a lot of the how do I get a certificate, presenting the certificate on the connection, rotating the certificate when it's expired. So taking a lot of that machinery, that boilerplate, that stuff that would otherwise, be error prone and tedious, and developers tend to cut corners at times. Take that out of the hands of the developer, put that into the infrastructure, and reuse it. Right, so the same idea that we had with the API gateway. Take it out of the developers, out of the apps, let them focus on business logic, differentiating things. The heavy lifting around security and all this stuff goes into some other component. And that's what the service mesh does, but it doesn't do it in a centralized model. It does it in a way that's app specific. So it's decentralized. So we can talk from service A to service E, in this case, and get the benefits of, in this case, mutual TLS, without the app having to worry about how do we actually get that in place. And now you don't need JWT tokens for service-to-service authentication. The app doesn't have to deal with trying to get that correct. It will happen in the network. And by establishing mutual TLS, service A knows that when it calls service E, that is service E, because that service presented a certificate that service A trusts, that says that service E, and vice versa. When A calls E, E will know that that is A. That is service A, because they presented a certificate from an authority that service E trusts. It's signed, and it will trust that that is service A. And then, so that's the mutual authentication part, and then the traffic will be encrypted. They do the TLS 1.3 or 1.2 handshake. They negotiate ciphers and keys, and then they communicate over a secure channel. So this is what the service mesh does. We think that makes the developer's life easier. Mm-hmm. It gives more confidence to the platform team that security is being implemented consistently and correctly. And I know we have a demo to show that. The last part I'll point out here is that in those certificates, we can use a common approach, a common standard for representing identity. And in the service mesh case, Istio specifically, we use SPIFFE. SPIFFE is the secure production identity for everyone, framework for everyone. And that is the foundation for getting workload identity in place, so that then we can write authorization or authorization policies about, the services can communicate, but what can they actually do?
So it's almost, if I try to like do a comparison, I guess, when we use the certificate in the demo that I did, right, we were using it merely for encrypting, right? We weren't using it to bake the identity of someone into it per se, right?
Yeah.
It is, I mean,
or if you did, or if you were doing it just on one side.
Yes. But this one is actually saying, one, it's encrypted, and two, it also tells you who am I with the actual, like the SPIFFE string, SPIFFE ID that gets encoded into the cert itself, right? So it's basically one artifact. There's no JWT token in this case. It's just certificates on both sides, right?
Yeah.
All right, so I can jump into the demo if you. Are we good for the demo?
We're good for the demo. I do want to point out one thing, or at least restate one thing, because somebody might be sitting there saying, well, in the sidecar, using certificates, that sounds good, but could you just use the sidecar to do the JWT stuff in it? And SPIFFE supports JWT, and so on and on and on. That's true. None of the service meshes that I know of, support using a JWT based. They call SPIFFE calls it SVID. And the reason for that is, compared to certificates, In the certificate model, the secret, highly sensitive material never gets sent over the wire, right? When we do mTLS, we'll send the public keys or public certificate, right? And then that gets signature checked and so on. In the JWT case, we send the sensitive material. The JWT token, the bearer token, is the secret. We do send that over the wire, and so technically you can build a service mesh that uses JWT tokens as the underlying mechanism for mutual authentication. But if you look at it from the standpoint of, well, if you could do it in mutual TLS, do it that way. If you cannot, then do it in JWT, and you'll see most of the service meshes use mTLS. But okay, go. I just wanted to make that point. Go ahead, and actually, I think the Spiffy docs say that too, something along that lines. But yeah, go ahead and let's dig into the next
demo. All right, let me do this. All right, so I have a small diagram that just it will show what I'll actually show you the demo of. So I have a Kubernetes cluster set up. I've installed Istio on it. Let me see if I can make this more organized. I won't be able to make it, but anyway, I have three apps deployed. I have the web UI. I'm very inventive with my service names. Web UI at a backend, but then I also have it's called second backend, not another backend, but I have basically three services: a web UI and two backends. I have an Ingress gateway, Istio Ingress, where I'm exposing this web UI through. And what I've done is I've implemented and or used third-party library. I'm using Node.js, just the simplest way to get everything up and running. Some auth library to talk to auth0 in order to get my user JWT token. We're not using JWT here for services. I'm using it for user auth specifically. And then I'll show you how you can layer in the service auth as well, and combine both in an authorization policy that encompasses both the JWTs and the service identities as well. All right, so let me find the window and I'll open a new window here. And I have this exposed on locally, of course, on web UI test. So this is my web UI. I can make it a little bit bigger. My web UI, it makes a call from backend to the backend API and to the second backend API, and just gets back a response, right? So there's nothing, no authorization policies yet, nothing deployed. So let me show you how you could do this. So the first thing that you would typically do is, let me zoom in. You would deploy an allow nothing authorization policy that doesn't allow any services to communicate, right? So this is just denying everything outright. And then what you would go and poke in holes, right, for the services that that have to talk to each other. So let's refresh. Notice I'm getting RBAC access denied right away because the Ingress is not permitted to talk to web UI. That's the first step, right? So we have to, how do we fix this? Well, we can create an authorization policy. We're layering it in on top and saying the Istio Ingress gateway, or the pod with this identity, or the service with this identity, can make calls to the web UI, right? So let's do this one. So this is first piece of the puzzle here. If I go back to the page and restart, or refresh rather, I can get to the UI. However, now the web UI can't talk to the backend services, so I get back a 403 on both of them, right? So we have to fix that one as well. So I'll just fix one. I'll just say, hey, you can make calls to the backend API only. Let's do that. Let's apply it, refresh, and there you go. I'm able to get back the response from the first backend API. So this was all authorization policies based on which service is calling which service, right? And this is doing by default mutual TLS, right? It's using certificate. There's no JWTs here. So what I'll do next is I have implemented user auth as well on that UI portion, right? And I can layer it on top and say, well, in addition to web UI calling back an API, it can only do that if a specific if a user is logged in, right? Let's put it that way. So the first thing that I'll do is I will create a request authentication policy. And what this policy does is it's going to say, hey, I require a JWT token to be present in the requests from the front end, right? In this case, because front end is calling it, or web UI, to the backend API, right? So we're saying calls to the backend API require a JWT token with this issuer and use these public keys to verify the token is correct. Now, what I didn't show you beforehand, I set up the auth0 secrets and everything, right? So so my web UI has access to those values in order to do the auth, right? So what we're doing with this, we're just saying, hey, we require the request to have that token, and it was issued and signed by that specific tenant. Now, if I refresh the page, like this should still work, right? And the reason this is working is we have to make use of that request principle in the authorization policy. So this is the same authorization policy I had before, but this time, in addition to saying, well, only this service can call back in the API, I can also say, well, it also has to have a request principle set. I'm setting it to star here, but you could be extremely specific here and say Peter at solo.io or something, right? Or whatever my user principle is. So let's do this one. So apply this one. So this one was configured. Now, if I go back, notice before we were getting this back still, but this time I'm getting a 403 again, right? So at this point, what user would have to do, you would have to go and log in. So the log in. Continue. And now I'm back, and you're seeing that I do get back that authorization policy is in effect, right? And it's allowing me to get back the responses from that service. And just to prove that this is real stuff, right? These are the claims that are associated with the user that I logged in with. And what you could do in that authorization policy, you could use any of these claims. I don't have any extra claims set, right? But you could make use of these claims to say, well, only JWT tokens that have the claim nickname set to Peter are allowed to do something, right? Or are not allowed to do something. Yeah, and then just to show that this works through the UI, if I would go and try to send a request from the web UI, right, directly to the backend API. Now, no, in this case, services can talk to each other. That's allowed, but I don't have that JWT token set, so I'll get RBAC access denied. And then if this is assuming someone gets access to your cluster, right? Let's say, and they're trying to call the services. So it's not going to work. And even if they do authorization bearer and something, whatever, right? It's not going to work either because the JWT token in that case is not correct, right? So this is just showing you how you can layer the two things together, use JWTs for your user auth, and then leave the service to service to Istio and have Istio deal with that instead. All right, let me switch back to you, Christian. There you go.
I want to be mindful of time. I know I actually have a hard stop, but I think what we've talked about so far is that there's a number of ways to do service-to-service authentication. What we've seen in the wild is that you can use JWT tokens. There's a number of considerations that you have to have, and a number of things you have to do to get it right. And it's easy for development teams across a large organization, every single team, to get it wrong, actually. And like I said, I'm not trying to be flippant, but this is the stuff that we've seen, and that is why the service mesh, a big part of the value. When I hear people say, yeah, the service mesh will give me encryption, it's actually much more than just encryption. It's getting you service-to-service authentication.
Mm-hmm.
It's alleviating your developers from having to worry about that stuff, simplifying their lives. It's giving you workload identity, and so strong workload identity that then you can write authorization policies about in a consistent way, a transparent way to the applications, and it can be changed, through automation or declarative configuration or whatever, instead of going back to the developer saying, hey, can you make this change? And they're going to say, well, attach that to a project ID and we'll figure it out or whatever in our next sprint. But these are, when we're talking about security, you want to be able to respond when you need to. You want to do things the right way and consistently, and not just leave it up to each team to sort of invent their way to do it. And that a service mesh brings a tremendous amount of value to solving these types of problems. So yeah, I'm curious to see whether we got questions, and happy to take questions. Happy to take things offline. I know with the person that asked specifically about checking the expiration. Mm-hmm. I mean, let's take that offline. Let's see if there's either something that we do in our gateway, or whether that's something that we can contribute upstream. Yeah. We're very involved in the upstream Istio community here at Solo. So we want to be able to help as much as possible.
Yeah, Arjun. By the way, Christian, if you have a hard stop, I still want to do I still have 5 minutes at the end. Want to do the demo, okay. The last demo. So if you want, feel free to drop off at any time. But Arjun had a specific question. He's using a JWT minted from Azure AD. When validation, I'm assuming this is Istio. When validation is happening, I get JWT verification failures, and it doesn't give me much information in Istio logs. I don't know explicitly, if you saw in the demo what I did get a specific a more specific error, right? But what I would do personally, if you have access to that JWT token, figure out, is it expired? Is it something else that's missing? It's very hard to answer why explicitly is it failing.
And for this person, reach out to us on Slack. Mm-hmm. I mean, the Istio data plane has a lot of knobs for
configuring,
getting very fine-grained logging and potentially getting more information. But if we take a look at your specific case here, maybe we can get more detailed. Mm-hmm. But yeah, reach out to me on Slack. I'm CE Posta or Peter, mm-hmm. And then we can try to help.
Yeah. All right, I'll jump into another demo. Christian, feel free to drop off if you have to. Thanks for stopping by, and thanks for doing this. It was I hope others found it really useful as well. Definitely was useful for me.
My pleasure.
All right, and I'll go through the last demo that I have prepared, because it just kind of builds on top of the previous one. So in this, and I just want to show the differences, right? In this case, all the auth stuff was happening on the web UI side, right? So web UI had the code to go access to the secrets for Auth0 and everything it needed to go to Auth0 and do the auth there, right? Now the scenario, the last one that I'm going to show, is exactly the same scenario. However, in this case, I'm using Glue Gateway, and Glue Gateway has the ability to do the OAuth flow for us. So I don't have to implement anything in the web UI, right? So the Glue Gateway is the point where people will get, or users will get, redirected to Auth0. So let me just show you. Open Windows here. And Arjun is saying if I use expire, it says expired, but if I use valid JWT, then it says verification fails. Interesting. Please reach out on Slack. It might be like your keys, verification keys, or keys that you're using for verifying the JWT tokens are not correct or something like that. But definitely we can figure it out. So, all right. So it's the same thing. Now, this time I have same thing running, but this time I do have Glue Gateway running with an external auth service as well deployed. So let's see how we can set this scenario up. So we will configure Glue Gateway to actually do the auth flow instead of the web UI, right? So I was earlier when I was talking to Christian, it's almost like previously service meshes help you push out the like retries, right? Timeouts, all that logic to the network. In this case, you're pushing out this auth stuff to the gateway, right? So you don't have to worry about it. Let me find the, oh, there it is. Okay, so Glue Gateway. So I've installed it. I have a secret. I've deployed everything. I've configured my virtual gateway so I can access the thing, configure the route table. And then I'm using the label. So this is Glue Gateway specific resources here, right? Where you can label specific routes. And then when you're applying auth policies, you can say apply the auth policy to a route table with this specific label set, right? So it's just a way to do that. All right, so what I'll do first is I'll deploy this external auth server configuration. This is just saying use the one that comes with Glue Gateway. I'll create a secret, but I think I already have this. Let me just double check. Oh, that was script auth0. I already have it deployed. And then I'll configure the external auth policy, right, with auth0. Notice I'm applying it to all the routes that have this OAuth set to true. And then I'm setting these values here instead of setting them in, configuring them as secrets or configuration or whatnot for my web UI. I'm setting it here in the external auth policy. So let me just get my, let me see. Let me just move off the screen a little bit so I don't flash the secrets, but not that it matters. It's a test one. But I'm just filling out the client ID and the issuer URL so I can deploy this. Yeah, there it is. All right. There you go. So I have my client ID. This is, if you're setting this up on auth0, these are the values that you get from them, right? So you get the client ID. I'm referring to the secret that I deployed earlier, and I'm using the issuer URL that was given to me by auth0, defining the scopes, logout path, and then over here, what I can do is I can even say, hey, Glue Gateway, put the ID token that you get once you've authenticated with auth0 into the JWT, into a header called JWT, and put the access token header into a header called my access token. And then additionally, I'm also saying also extract these claims and put them as headers, right? So what you can do is you can have your gateway do the auth, put the headers if you want to use them later on, if you want to, right, into specific headers, put the JWT, right, or the ID token or the access token in specific headers. But additionally, you can say, but I also want you to extract these claims and put it as headers as well, right? So let's do this. And then finally, you're just referring back to that external auth server. Let's apply this one. It was created. And this time, if all works well, let me actually minimize this. If I refresh this page, I should get prompted to log in right away. So let's see. Oh, I'm actually, let me reopen. It's picking up an older session. There you go. So if I go to HTTPS web UI test, yes, I'm using a self-signed certificate. That's why I'm getting this. And you notice I get redirected to my auth0 tenant, where I can log in just like I did before. There you go. And I get back the same page I did before. I can look at the profile. It's the same same set of claims I got before as well, right? The only difference now is that I'm doing this at the gateway level, right? Then what you could do is we could go and repeat the same thing, right? We can say, well, allow nothing. I'm using Istio. I closed the window, so let me reopen it again. So if I go web UI test, this one will still going to bring me here. So it's not regard. So if I would do, let's do solo here, I should get auth denied or RBAC denied. There you go, right? So I get RBAC access denied, right? Because we have allow nothing. And this is pretty much the similar authorization policies as before. The different thing is the principal, because this time we have the gateway that's running in a different namespace. It has a different service account, but everything else, the authorization policy, the request authentication are exactly the same. So if I would deploy this, let's refresh, and boom, I should be, there you go. I'm back at the same state that I was before, only getting responses back from the first one, but not from the second one. Yeah, so this was just a way to show another option of, instead of having auth on your services, you can also push it out if you want to into your gateway and have gateway deal with the JWTs. Again, JWTs for the users, not for services, right? And then use them in authorization policies later on. All right. Well, thanks everyone for joining. I'll wait around a couple of minutes, second, if someone is asking a question. Oh, there's a question that I missed. So Code Coffee. So we should avoid access tokens JWTs from auth server, only accept mTLS for service to service, but how? No. So the thing is, use JWTs for your user authentication, and then try not to use JWTs for your service to service authentication, right? In Istio, you can get the service to service mutual TLS pretty much for free because it's done at the sidecar level, right? If you want to know the user ID, you still have to do JWT, right, with auth0 or whatever your whoever your provider is, right? What we're trying to say is that we, with some customers, we were seeing that people sometimes try to use JWTs for service-to-service communication as well, right? And there's easier and much better ways to do that with mutual TLS and with service mesh with Istio. For your user auth, yeah, JWTs are the way to go. So we're not saying don't use JWTs, right? All right. Thanks everyone again. If you have any questions later on, you can reach me either on Twitter. You can reach me on Slack.solo.io. Both Christian and I and other solo people are there as well. If you have any questions, and I'll follow up with Christian and Arjun if you want to either ping me on Slack or something, and I'll gladly follow up with you. Thanks again, and join us next time. I don't know what the topic will be. Again, if you have ideas, let me know. But thanks for joining, and I'll see you next time. Bye, everyone.